On our next problem, notice that we have a trinomial in the denominator, which means I really want to factor that out to see if it can break down anymore. It looks like it's going to be x plus 2 and x minus 1. Factoring is really going to help you to pick the least common denominator. The LCD here is you have to have an x minus 1 factor, you have to have an x minus 2 factor, plus 2, excuse me, and then this says you have to have an x plus 2 and an x plus 1, but x minus 1. And then the last fraction needs an x plus 2, I already have it, and it needs an x minus 1, I already have it, so that is my LCD. So now I am going to multiply every single numerator by that LCD. I'll do that in green. Please don't be lazy, write this all out on every single numerator. It's when students don't do that they start making mistakes. I know it's a little bit scrunchy in there, but go ahead and just do it anyway. Alright, so on the first fraction, the x minus 1 factors divide out, and you're just left with 3 times x plus 2. I don't distribute that in my head. I do that on another step because sometimes if there's negatives, you need to remember to distribute the negative with it, so I find it helpful just to write it out for one step. So on the next fraction, x plus 2 divides out, so I'm just going to write this out at 4 times x minus 1. Write it out so that you don't accidentally make mistakes later. On the third fraction, the x plus 2 and the x minus 1 all divide out, and again you're left with 16. In one step, you've taken a fraction problem and turned it into a much nicer whole number problem that we can solve now. So we're going to add the x's to get 7x, add the numbers to get plus 2. Notice that this is linear. There is no squares. Yay! I just count my blessings there. I'm really glad that there's those squares. So I just have 7x is equal to 14. Divide both sides by 7. And x is equal to 2. Yay! I'm really glad that that was linear and I didn't have to do a whole lot more work. So I only have one potential answer. To check that one potential answer, I'm going to plug 2 into the denominator. So I have 2 minus 1. Is that equal to 0? Nope, that's equal to 1. I'm good there. Plus 4 over 2 plus 2. Is that 0? Nope, that's 4. So we're good there. And then the third denominator, I have 2 squared plus 2 minus 2, which is what? 4 plus 2 minus 2, which is 4, not 0. Yay! So this is a good solution. I've checked for the bare minimum of making sure that the denominators aren't 0, so I don't have an extraneous solution. I didn't really check for accuracy, but I did check for the extraneous, which is the required check. On our next problem, I have to factor again. It looks like on this denominator I can factor GCF of x out. So my LCD is going to be x and x minus 2. Each one of those copies is only being raised to the invisible 1. So that's my entire LCD. Now I'm going to take that LCD, x times x minus 2, and multiply it to every single numerator. If I pick the LCD right, all of the denominators should magically go away. So the x minus 2 divides out, and I'm left with 3x. On the second fraction, the x's divide out, and I'm left with minus 2 times x minus 2. Don't distribute that out. If you try to distribute this out, you might miss that the negative is attached to the 2 and that you need to distribute the negative with it. That's a common student mistake. On the third fraction, the entire denominator divides out, and all you're left with is 6. When I distribute, I'm getting, oh, linear, yay! I don't have any squareds, that's good news. So I have 3x minus 2x, which is 1x. And then I'm going to subtract 4 from both sides and get x is equal to positive 2. So this is my potential answer, but I must check. To check, I just plug 2 in every time I see an x. Okay, so on the first fraction, 2 minus 2, that's 0. So 3 divided by 0 is undefined. So because we have a 0 in the bottom when we plugged in our answer, clearly our answer can't be true, because if you have a 0 on the bottom, the whole thing is invalid and doesn't make any sense. So because of this one right here, even if the other ones seem like they're okay, if one of the denominators turns out to be 0, then this is not a valid solution. It's an extraneous solution. I have to eliminate it, and then I would write no solution. Please don't scribble out all this work. Just because it's an extraneous solution doesn't mean you've made a mistake. Please put x equals 2, like the green I have here, and then put like that red x I have right on top of it. A clean x, so I can give you credit for getting x equals 2, and then I can also give you the last bit of credit for knowing that it's an extraneous solution, and that the true answer is no solution. On our next problem, I'm going to factor again. I have x and then x plus 1. My LCD looks like I have to have an x plus 1, and that's raised to the 1, and I have to have an x. I have to have one of each. So that is my LCD. I'm going to multiply that to every single numerator. Don't be lazy, write it all out. Okay, on the first fraction, the x plus 1 divides out, and I'm left with 3x. On the second fraction, the x plus 1 divides out, but so does the x divide out. So then that leaves me with 2x plus 5. Again, this is linear. Yay, I like linear because I can just get my x's on one side of the equation, the numbers on the other side of the equation, and then I can divide if I need to. In this case, I don't need to divide because it's just 1x equals 5. So this is my solution, I think. Because I don't know yet, I have to check. So I have 3 over 5 plus 1 is supposedly equal to 2 times 5 plus 5. But really, I don't care about the numerator. All I'm really checking is to make sure that those two denominators aren't 0. 5 plus 1, that's not 0, that's 6. 5 squared is 25 plus 5, that's not 0 either. Yay. That's the only check that I'm required to do. On our next example, we don't have anything to factor in either of the two denominators. So I'm going to skip that step and go straight to the LCD. So my LCD here has to have a 5x plus 3 in it, but it also has to have an x minus 1 in it. The two factors, the two binomial factors, don't have anything in common. So I'm just going to go ahead and multiply both sides by that LCD, which is 5x plus 3 times x minus 1. 5x plus 3 times x minus 1. Please don't be lazy, write it all out. The 5x plus 3 divides out, and I'm left with 5 times x minus 1. On the right-hand side, the x minus 1 divides out, and I'm left with 5x minus 2 times 5x plus 3. Don't forget to put that binomial 5x minus 2 in parentheses, because the bar is a grouping symbol which groups the whole numerator together. So that gets me 5x minus 5. On the second half, we get 25x squared plus 15x minus 10x minus 6. Now look at the x squared. Because I have an x squared, this is going to be a quadratic problem. Because it's quadratic, I want to get one side equal to 0. Oops, accidentally, the linear term added to 0. Oh, and that looks factorable to me. 5x plus 1, 5x minus 1. Set each of those factors equal to 0. So my two potential solutions are negative 1/5 and 1/5. Okay, so I'm running out of room here to do my checks, so I'll just do the bottoms. So I have 5 times negative 1/5 plus 3 on one of the fractions, and then negative 1/5 minus 1. Well, fractions aren't all that fun to do, but the 5's divide out here. That's really easy. That's just negative 1. Negative 1 plus 3, that's not 0. Negative 1/5 minus 1, well, that's something, but it's not 0, so I don't really need to worry about that one, so negative 1/5 is good. When I'm doing positive 1/5, again, I'm just going to look at the bottoms. 5 times 1/5, well, that's 1, and 1 plus 3, that's 4. Okay, so that's good. On the other side of the denominator, I have 1/5 plus 1. Well, again, I don't know what that is. I mean, I would have to do some fraction work to work on that, but it's not 0, I can tell you that. So I know that both of these are good solutions. Alright, on our last problem here, it looks like everything is already factored in the bottom. So I'm just going to go straight for my LCD. Nothing is repeated, so I have to have one of each type, x plus 2, x minus 2, and I'll put a 2 there in front. I have to have each one of them. So then I'm going to multiply every single numerator of every single term by the LCD. I know that's a lot of writing. You might be tempted not to write it all out. Don't do that. Write it all out, please. On the first fraction, the x plus 2 divides out, and I'm left with 2 times 2x plus 4 times x minus 2. Don't try to distribute any of those out. You might miss some factors. So then bring down the minus. The x minus 2 divides out on the next one. Then I have 2 times x plus 3 times x plus 2 equals, and then on the last one, the 2's divide out, and I'm just left with x plus 2 and x minus 2. Now, when you have 3 terms and you're trying to multiply those 3 together, you can really only do 2 at a time. I'm going to choose to multiply the second 2 together, and then I'm going to multiply all of that result by the 2. So let's go ahead and do that. 2x squared minus 4x plus 4x minus 8. On the other one, I'm going to do the same thing. I'm just going to multiply just the insides, and then I'm going to come back and multiply the 2. You can't multiply 3 things at the same time. Even if you try to do some simple multiplication in your head, you really just do 2 things at a time. So I'm going to multiply these 2. On the right hand side, there's only 2 terms, so that's going to be easy. So I have, back on the left hand side, I'm going to distribute the 2 all the way through. So that gets me 4x to the squared minus 8x plus 8x minus 16. Again, distribute the 2 all the way through. Minus 2x squared minus 4x minus 6x minus 12. And then on the right hand side, I just have x squared minus 4. There's a lot of things to combine here on the left, so be very careful. I'm going to go ahead and underline every time that I combine like terms, just so I don't miss anything. 4x squared minus 2x squared is 2x squared. Minus 8 plus 8, well, those two add to 0. That's nice. And then minus 4 minus 6, that's minus 10x. And then we have minus 16 minus 12, which is negative 28. And now I can solve for 0. Because it's quadratic, I need to get one side equal to 0. So that gives me x squared minus 10x minus 24. I'm looking for 2 numbers that multiply to 24, yet add to 10, one of each sign. Please be careful, because on the factors of 24, We have 2 and 12 that seem like they add or subtract to 10. And then you also have 4 and 6, which seem like they add and subtract to 10. So here your signs are super important. Because I have opposite signs, I have one of each, I need to use the 10 and the 12. So it's going to be minus 12 plus 2. So if I set each of those factors equal to 0, I'm getting x is equal to negative 2 or 12. Those are my two potential answers. Now I'm not sure if either or both work, so I'm going to go ahead and check each one of them. So let's try negative 2 first. So I have 2 times negative 2 plus 4. But you know, honestly, the numerator doesn't matter all that much. All I'm really caring about is this denominator 0? Well, look at that. It is 0. Let's see, that numerator is 0. It doesn't really matter what the numerator is. Because that denominator is 0, x equals negative 2 doesn't even make sense. Notice I didn't even do the rest of the problem. It doesn't really matter. If one of the denominators is 0, then that's not a solution. Now, just because that's not a solution doesn't mean 12 can't possibly work. You just have to try each of them. So in the numerator, I have 2 times 12 plus 4 over 12 plus 2. Don't really care about the numerator. I'm really just caring about the denominator. Does 12 plus 2 equal 0? Well, no. I'm good. So let's try the next one. Minus 12 plus 3 over 12 minus 2. Again, not 0. Equals 1 over 2. Again, not 0. So 12 works, but negative 2 doesn't. And that happens sometimes. Just because one of them is extraneous doesn't mean the other one can't possibly be a good solution.